Hi guys, welcome to our channel Swipe to Learn. Today we will be seeing about the Python flowchart, its use cases, symbols and examples on flowchart. Flowcharts helps us to represent the process very easily. They are like simple visualization tools. We use different shapes to show steps and decisions clearly. Flowcharts are help in various purposes like where the user can know about the process and the problem statement, how he or she is solving it. It helps us to know about the problem statement for the developer and also in the help of documentation. Whether you are a beginner or an experienced developer, this video will show you how flowcharts helps you streamline your coding process and take your Python skills to the next level. Let's see about the flowchart. Several reasons like visualizing complex processes. It helps us to improve the communication. We also helps in identifying the errors and inefficiency to identify the potential errors, bottlenecks, and also inefficiency in the process. Flowcharts are often used to design and plan algorithms, making it easier to write the efficient code. It serves as an important purpose for documentation. We use for building in the logic, documentation, debugging, and optimizing. There are several purposes where when we see the flowchart, we go with and we know how the program is going to be executed. As you see here, it's start and also it takes in the input number. As you see here, it takes the start and end are very common for any of the flowchart. Then it reads the input number one, number two, and it's gonna perform the logic. Here it is adding the two numbers, like sum equals to number one plus number two, and then printing the sum, and then we are coming out of the flowchart. If you see this, it comes to know about like how we have to use it and come up with this flowchart here. Let's move on to next. As you see here, you see the symbols like where it represents the flow lines. These are called as the flow lines. They are used to connect the symbols and the terminal. These are used for the start and stop. Terminal is the start or a halt in a program logic. If you go with the parallelogram, it tells about the input and the output. It represents the information entering or leaving the system. And then if you go with the processing, it represents the arithmetic and logic instructions or the program logic. If you go with the rhombus, this is the decision making, where if while these come under the decision making. And this is a connector. If you write down with the flow chart, it's still you go with the pages, like you can't get a complete long paper, right? Or if you go with the serious dynamic programming or divide and conquer algorithm problems, you have number of series of steps that helps us to understand about the program. So we use the on-page connector. Like if you go with the end with the connector here, and then if you just place the connector here, the code will be going on there. So this is on-page connector, and then here it is used for the sub function. Like we have many symbols for this flowchart. We can just go and learn about different connectors. If you go on writing the flowcharts, then you come to know about different symbols. As you see here with the example, these are the examples of the flowchart. If you see here, it starts with the start and end. These are very common, either it may be start or stop. It is very common for the flowchart. Here it's reading the input, and if A is the input, it's reading if A mod 2 equals to 0. As you know, it's the functionality of even and odd. So if it is yes, as you see here, this is the decision making symbol, rhombus. And then if it is S, then we are going to print A. A is even. This is the output here, right? So output is given in the parallelogram. If it is no, then you print it as odd. See with the next one, you go with your start reading input. If A mod 2 equals to 0, that is even. Add with A equals to A plus 1. If it is not, then subtract A equals to A minus 1. Then here we go with the on-page connector. Whenever you see this on-page connector, you check in the page where it is. So here it is. So then the flow follows the next one. After completion of either incrementing it or either decrementing it, you have to print A and end this flowchart. Yes. Now you see output when n equals to 5. There it's first starting and then initializing sum equals to 0, count equals to 0. Enter n. say I am entering n as 1. So sum equals to sum plus n. Initially sum equals to 0, count equals to 0. Now sum will become sum 0 plus 1, that is 1. Count increases 1. Is count less than 5? True. Go again, take n value. Now I am going to take n value as 2. Sum will become 2 plus 1, 3. Count will be 2. It goes until count is less than 5. If it is count is less than 5, yes, it goes on repeating this loop. And if it is not, like count is equals to 5, then it's gonna print sum. After printing sum, it's going to sum. So it takes the five any of your 5 integers and prints them. This is the flowchart of this. Let's move on to next. What's the output here? As you see here, it also have start and stop. These are very preliminary. And then here it is count equals to 0. So print hello world. So first it's going to print the hello world on the output. And then count is incremented. Count equals to count plus 10. So now count will be 1. 1 less than 10, it's true. So it's go again, prints hello world. Now count is incremented to 2. 2 less than 10, no. So it goes on 10 times and the hello world is print as 10 times. This is the output for this flowchart. To see this, it will be simple. I think you may see it very simple to get into the flowcharts. Like these are very basic programs. When you go with the complex programs, if you see this kind of pictorial representation, it will be very easy to understand the program logic flow than reading 200 lines of code or putting them into a pictorial format in a single screen is very easy when you go with the complex problems. And this also helps in the placements where you get your flowcharts and your sample inputs and you have to match them with your sample outputs. So as you see with the next flowchart, I think if you go and see with the print, it's going to print the largest value, right? So let's go and analyze the flow. So the values are 10 and 15. And start, let's read the input values. As I told, inputs, outputs are used in a parallelogram shape. Value 1 greater than value. Value 1 is 10, 10 greater than 15 is false. So we are going to go this side, max equals to value 2. Value 2 is 15 here. And we are going to print the largest value, that is 15 here. This is a very basic one, right? Let's move on to next. So here the values are a equals to 1, b equals to -5, and c equals to 6. So now we are going to have the start reading the input values, calculating the discriminant. We know the formula d equals to b square minus 4ac. We got b is -5, -5 whole square, 25 minus 4 into a is 1, c is 6. 25 minus 24 is 1. Discriminant. Discriminant is greater than or equal to 0. It is yes. Then we are going with the S. And then we'll be finding the roots and then printing them roots. I'm just here to tell you about how to see whether it's the flow or not finding the some real values, right? Congratulations on mastering flowcharts and keep solving problems. When you go start writing the complex problems and making into a pictorial representation, say this is the input. This is your, suppose your problem is an abstract problem. This is your output. Fine, and like mapping the structures. So this is input. Then I'm going to start here. Read my input. Perform this logic. These are the set of logic. After this, it has to go. If you go with the pictorial format, it's very easy to you understand. I think you all remember you doing and writing the route maps for you from your school to your home, explaining your friends. From there itself, we used flowcharts, how to use them. So this is the same way we are using in solving the problems. Got it?